Hi everyone! For today's video tutorial, I'm going to explain number system, binary conversion, and binary computation. So first, what is number system? A number system is a way to represent numbers using a set of digits and rules. Each number system has a base or radix which tell us how many digits are used. For example, the decimal system or base 10 is the one we use every day. It has digits from 0 to 9, and the binary system or base 2 uses only two digits, 0 and 1. This is very important in computers because all data is stored and processed as 1 and 0. Now that we know the basics of number systems, let's move on to binary conversion. Every digit in a number has a place value. In decimal, place values are powers of 10. For example, 245 is equal to 2 times 10 raised to 2 plus 4 times 10 raised to 1 plus 5 times 10 raised to 0. In binary, place values are powers of 2. So the important rule, we always start from the rightmost digit with 2 raised to 0, then increase the exponent by 1 as we move to the left. So it goes 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, and so on. Now let's convert a binary number into decimal. The steps are: Step 1, write the digits downward. Step 2, assign powers of 2. Step 3, multiply each digit by its power. And last, add the products. So now, let's try converting 11010 in binary to decimal. So we write 01011. Next, assign powers of 2 starting with 2 raised to 0 at the rightmost digit, then increase by 1 as we move left. So the powers are 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, and 2 raised to 4. Now, multiply each binary digit by its corresponding powers of 2. So, 0 times 2 raised to 0 is equal to 0, 1 times 2 raised to 1 is equal to 1, 0 times 2 raised to 2 is equal to 0, 1 times 2 raised to 3 is equal to 8, and last, 1 times 2 raised to 4 is equal to 16. And last, add the products. So 16 plus 8 plus 0 plus 2 plus 0 is equal to 26. Therefore, the decimal value of 11010 in binary is 26. Now, let's convert from decimal to binary. The steps are: Step 1, divide by 2 repeatedly. Step 2, write the remainders downward. And Step 3, read the remainders upward. So, let's try converting 26 in decimal to binary. So first, we will divide the number by 2 and each time we write down the quotient and remainder. The remainder will form our binary digits. So, 26 divided by 2 is equal to 13 and the remainder is 0. 13 divided by 2 is equal to 6. The remainder is 1. 6 divided by 2 is equal to 3. Remainder is 0. And 3 divided by 2 is equal to 1. Remainder is 1. And last, 1 divided by 2 is equal to 0. Remainder 1. Next, we write the remainders downward in order as we get them. So, it gives us 0, 1, 0, 1, 1. And finally, to get the binary number, we read the remainders from bottom to top. So, reading upward, 11010. Therefore, 26 in decimal is equal to 11010 in binary. Binary computation means doing arithmetic operations like addition, subtraction, multiplication, and division using binary numbers. It works the same way as decimal arithmetic, but the only digits we use are 0 and 1. Let's start first with binary addition. So, here are the rules of binary addition. 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, and 1 plus 1 is equal to 1, 0, which means we write 0 and carry 1. Our example is 1011 plus 1101. Now, let's add the numbers step by step. So 1 plus 1 is equal to 0, carry 1. 1 plus 1 is equal to 0, carry 1. And 0 plus 0 is equal to 0. 1 plus 0 is equal to 1. And 1 plus 1 is equal to 0, carry 1. 1 plus 1 is equal to 0, carry 1. And 0 plus 1 is equal to 1. Bring down 1. And that's all for today's video. I hope you learned something.